Good evening, good morning, wherever you are. Hoping you had a good day today. My name is Teacher David. I want to take you through my predictions and make sure you go through step by step all of them from the beginning to the end as you write down some things. Then after you have gone through this video, down here there is mahali imeandikwa description. Finya hapo mahali imeandikwa more. Ukifinya hapo utapata link ya kudownload some paper yenye nitaweka hapo, a question paper and a marking scheme, right? So after you have gone through this video, you will download that paper, then try, because nimeweka the table, I have the figures in the tables, I have the observations for you, so yours is to make sure to see whether you can write the correct answers as you prepare for your paper 3. If you are unable to download, you can reach me, sio sasa usiku. You can reach me mapema. I send you the papers through WhatsApp if you cannot be able to download.
My name is Mora Evelyn and my dad is Mr. David. My dad will take you through chemistry paper 3. Welcome. Remember to share, like and subscribe. Welcome. Thank you.
You are provided with solution A, hydrochloric acid, solution B containing 8.8 grams per liter of sodium hydroxide. This is the same as 8.8 grams per dm cube. So 1 dm cube is the same as 1 liter, and 1 dm cube is the same as 1000 centimeters cube. 1 dm cube is equal to 1000 centimeters cube. Provided with 0.5 of an impure carbonate solid Q. Solution C contains 2 molar hydrochloric acid. So 2 capital M means molarity. M stands for molarity. And the molarity is equal to the number of moles in a liter in 1000 centimeters cube. So what this means, it means that the 2 is equal to the number of moles in 1000. So let's go to what we are required to determine the concentration of solution A in moles per liter, percentage purity of the carbonate solid Q. Let's start with procedure 1. Fill the burette with sodium hydroxide solution B. Pipette 25 centimeters cube of hydrochloric acid solution A into a conical flask. Add 2 to 3 drops of phenolphthalein indicator and titrate until the permanent pink color appears. Repeat titration 3 more times and then complete with the potted table. Initial always use 0.0. Then fill the table. So you do the experiment, you will get your values. Find the average. So the average, I'm going to do the average for all of them, because when I look at these values, each, the difference is 0 plus 2, plus or minus the difference between these values. If they are not between, if if for example this was 23.5, this one was 23.5, it means I would not include it in the average. I will do the average with this and this only. But now since they are close within this range, then I will do the average with all of them. The average should be given to 2 decimal places. That's why even if it is 24, I have indicated with 2 zeros to indicate that it has 2 decimal places. Determine the concentration of solution B in moles per liter. So solution B, you go back and check what you are provided. B, we were given B contains 8.8 per liter of sodium hydroxide. 8.8 per liter. So this one is in a liter. So we need concentration in moles per liter, and that is called molarity, because I have told you molarity is the number of moles in a liter. So, sorry, morality, not moles. Morality. Morality. So, morality, mass in grams per liter or per dm cube, whichever, RFM. So, if I want morality, if I want the concentration, then remember that morality is exactly the same as concentration. It's the same as concentration in moles per liter. When you are asked to calculate the concentration in moles per liter, they are asking you to calculate molarity, because moles per liter is concentration, because molarity is the number of moles in a liter, concentration moles per liter. So they are asking you the same thing. Therefore, you write here molarity is equal to mass in grams per liter over FM. So we are talking about solution B, which is sodium hydroxide. So our B is sodium hydroxide. Let's get the RFM. We have been given these values here. 23 for sodium plus 16 for oxygen, plus 1. The answer is 40. The RFM is 40. Right? Then now, mass were given 8.8 divided by 40. And that is the concentration of solution B in moles per liter. So now we have the concentration in, this is the number of moles in 1,000. Determine the concentration of solution A in moles per liter. So we are also asked to find molarity of A. Molarity of A. So, but when you go back to the what we were provided with, we do not have much information about A. We don't even know anything. We just know the volume. We used 25 of A. That's what we know. But we know that A reacted with B. This is HCl and this is sodium hydroxide. Therefore, that is the information which we have. We know that A reacted with B, HCl plus sodium hydroxide. Therefore, I am for sure know that it is sodium, solution B, that reacted with solution A, HCl, which forms sodium chloride plus water. So when I look at this equation, the ratio is 1, 1, 1. But I know here this was 24 centimeters cube. The molarity for this one is 0.22 capital M. This one is, I know only the volume, which is 25. So I start from where? From known to unknown. We start from the known to unknown. So once we get the number of moles of sodium hydroxide, automatically we will get the number of moles of HCl solution A, because we know the volume and we know the ratio is 1 to 1. We know the ratio is 1 to 1. So let's start with what we know. So 0.22 capital M means number of moles in 1000. We will ask 24 centimeters cube. The one used will contain how many moles? So you will cross multiply. You will this times this over this. And this one will give us 0. The moles will be 0. So this is the number of moles. This is the number of moles of solution B that reacted with A. But since the ratio is 1 to 1, it means the number of moles of sodium hydroxide that reacted would be the same as the number of moles of 25 centimeters cube of solution A, because this is what reacted and the reaction came to an end. Therefore, moles of 25 centimeters cube solution A would be exactly equal to 0.00528. The reason, the ratio is 1 to 1, right? So now we have moles in 25 of A, but we are asked concentration, and that is molarity. Molarity is the number of moles in a liter. Therefore, you ask, if this one is in 25, what about a liter? 25 centimeters cube is equal to 0.00528. So what about 1000 centimeters cube? You cross multiply 1000 times 0.00528. You divide by 25. And the final answer gives you 0.2112 capital M. So if the molarity is too long, you can give to 3 decimal. It's always important to give to 3 decimal places. It's the same as 0.211 capital M. You can give to 3 decimal places. Procedure 2. Using a measuring cylinder, measure 12.5 centimeters cube of solution C into a 250 beaker. Add oral solid Q into the beaker containing solution C. Transfer all of the solution into a 250 volumetric flask and top up to the mark using distilled water. Label this solution D. Fill the puree with sodium hydroxide solution. The pipette 25 centimeters of solution D into a conical flask. So let's go step by step. Solution D, solution C was what? You go back to the what you are provided and check. So solution C was hydrochloric acid 2 molar. So we are measuring to 12.5 over this, 12.5 centimeters cube. After measuring 12.5, we will add the solid in a beaker. So the reaction will take place. So we will remain with, after the reaction, after the solid C, after solid Q react with the solution solid C, some moles will remain. And the volume will remain to be 12.5. The volume will not change. Then now we are going to derive this 12.5 into 250, we are transferring the remaining the solution, the mixture now after the reaction. We are transferring this 12.5 into a conical volumetric flask 250. Then we top up to 250. Then we will label that solution D. Now we are going to use D. D is HCl. The difference between the original and this one is the number of moles have decreased, and the dilution, we have diluted it. It is HCl, but the moles have decreased because the initial, some moles were consumed when reacting with solid Q. It means that then the number of moles that remains will be equal to the volume. The number of moles in 250 centimeters cube solution D will be equal to the number of moles of the number of moles that remained after reacting with solid D. I'm saying that the number of moles that remained in 12.5 centimeters cube will be equal to the number of moles in 250 centimeters cube solution D that was prepared. So we are using solution B. Remember, this is sodium hydroxide. So sodium hydroxide is reacting with HCl. The same reaction as this one. It is the same reaction as this one. The difference between the solution C and the solution D is the concentration, but it is HCl. So let's get the average. I have my table filled up. 8.5 plus 8.5. Calculate the number of moles of hydrochloric acid in 25, solution D. So solution D, we have pipetted 25. So D has reacted with B. So the volume of B sodium hydroxide is 8.5. This one is the one that brought the reaction to an end with 25 of D. But when you look at D, we do not know anything about solution D. D, we don't know anything about it, but we know much more information about B. B, we know the concentration, we know the volume. So that's where we begin, from what we know to what we do not know. So B has reacted with D. We know the concentration, the molarity of this, we know the volume. So the molarity of this was 0.22 capital M. You go back, if you forget, you go back and check B. The molarity is here. Number of moles in 1,000, we know that. And this is the number of moles. Molarity means number of moles in 1,000 centimeters cube. So we will find out what will be the number of moles inside 8.5. 8.5 centimeters cube will contain which? It is 8.5 times 0.22 divided by 1,000, and this one will give us the number of moles, which is 0. So this is the number of moles of solution B that reacted with 25 centimeters cube of solution D. But we know that this is sodium hydroxide and HCl, therefore the reaction is the mole ratio is 1 to 1. So the mole ratio is 1 to 1. It means that the number of moles of B in 8.5 centimeters cube will be exactly equal to the number of moles of 25 centimeters cube solution D. So moles of 25 centimeters cube D is 0.00187 because the ratio is 1 to 1. Determine or calculate, we start the question here, calculate the moles of acid in its 250 solution D. So immediately we get the number of moles in 250. We get the number of moles that remained after reacting with solid Q. So we have in 25 of D 250 tutapata kwa urahisi. 25 centimeters cube of D contains 0.00187 moles. 250 centimeters cube of the same D will contain 250 times 0.00. You go cross multiplication this way. 187 divided by 25. And this one will give us 0.0187 moles. So this is the number of moles in 250. And mind you, this is the number of moles that remained after solution C reacting with solid Q. Some moles were used up, right? And the one that remained will be equal to the volume of 250. And we have found the number of moles in 250, the volumetric flask solution. It means this is the number of moles that remained after reacting with the solid Q. Calculate the number of moles of hydrochloric acid in 12.5 centimeters cube of the original hydrochloric acid solution C. So we want the moles, but we know from what we were provided with, we know the molarity of solution C, the original, it is 2 molar. 2 molar, 2 capital M implies 2 moles are in 1,000 centimeters cube. So we will find out 12.5 centimeters cube will contain how many moles, because that's what it means. So this times this divided by this. 12.5 times 2 divided by 1,000. And this one will give us 0.01. 0.025 is the number of moles of the original 12.5 centimeters cube that was used. Now calculate the number of moles of hydrochloric acid that were used up in the reaction with solid Q. Very, very important. Now we know the moles of the original. We know the number of moles that remained. So we will know the number of moles. So this one is Roman 3. Is here. The answer in Roman 3 minus answer in Roman 2. Now we know the number of moles in 250 centimeters cube solution D are the number of moles which remained after reacting with solid Q. Now we know the original moles. So how do we get the difference? It is the original minus this will give us the number of moles that reacted with D. Number of moles of HCl that reacted with D. So it is the answer to get the number of moles of HCl that reacted with Q is answer in original Roman 3 minus answer in Roman 2. Zero 0.063 moles. So this is the number of moles that reacted with solid Q. Number of moles of HCl. Calculate the number of moles of the carbonate that reacted with the hydrochloric acid. Number of moles of Q. First, you need to know the reaction ratio. When a carbonate reacts with an acid, this is the equation you need to know, ionic equation. This is hydrogen ions in the acid plus the carbonate. It forms water plus CO2. So when you balance this equation, you find that the ratio is for the HCl and the carbonate is 2 to 1 from this equation. Therefore, if the number of moles of the acid is this, which represents 2, what will be the number of moles of 1? It means it is going to be a half. So it is a half times 0. So the number of moles of the carbonate is 0.00315. This is the number of moles of the carbonate because it is a half of that of HCl. Determine the relative formula mass of the carbonate. Given that the relative LFM of the carbonate is this, calculate the mass of the carbonate that reacted. Calculate the mass of the carbonate. From this triangle, we know how to calculate the mass. So moles, mass, RFM. What we are looking for, the mass of the carbonate. So mass, from here, mass is equal to moles times RFM. So our moles, the moles of the carbonate is 0.35. You multiply with the RFM, which is 106. And this one gives us 0.3339 grams. So it means this is the mass of the pure carbonate. The other remaining, remember the total was 0.5. The solid Q was 0.5. It means the remaining, it is the impure one. So we have obtained 0.033. It means that is the pure one. So how do you calculate the percentage purity? It is the mass of the pure, 0.3, over the total, 0.5. You multiply 1,000. You multiply 100, sorry. So this one will give us 66.78%. Number 2, you are provided with solid L. Carry out the following tests and write your observations and inferences in the spaces provided. Describe the appearance of solid L. So when you are trying to describe the solid, you take your solid and study the color. Which color is this solid? You can see it is white. Then you can see these are crystals. See? So when you are told to describe, you give the color, and if it is crystals, you give it is a crystal. For this one, it's a white crystal. White crystalline solid. It is a white crystalline solid. A white crystalline solid, as you can see. Place a third of the spatula full of solid L in a clean dry test tube. Heat gently, then strongly. Test any gas produced using moist red and blue litmus paper. You dip the litmus paper in distilled water, then put it on the mouth. Put them, the blue litmus and red litmus paper, put them at the mouth of the test tube before you start heating. Otherwise, if you heat then put the litmus paper, you are doing useless work. You put the litmus, moist litmus paper and the blue and red on the mouth before you heat. So the first thing you expect, if this solid contains water of crystallization, then you will observe that at the mouth of the test tube there are some droplets of water. But you don't tell us it is water. Who told you it is water? So the correct way of saying that, you say a colorless liquid is formed at the cooler parts of the test tube, or droplets of a colorless liquid is formed at the mouth of the test tube, right? So that if that is the case, then it means that this solid L is hydrated. In other words, it contains water of crystallization. So you will say solid L is hydrated. Or when I say or, you don't need to use this one. You can say solid L contains water of crystallization. So you choose one. Either you say solid L is hydrated, or you say solid L contains water of crystallization. You pick one. Then what will happen to the litmus paper? Red will remain red. Blue litmus paper changes to red. So if blue litmus paper changes to red, what changes a blue litmus paper to red? It is an acid. So it means the gas that was produced is an acidic gas. Therefore, say acidic gas present. Or instead of writing acidic gas present, you can simply say hydrogen ions present. And that is all we need you to do. Place all solid L in a boiling tube. Add about this of distilled water and shake. The solid dissolve to form a colorless solution. So we are going to write the inference here. But before that, I want to take you to number 3. This is number 2. Number 3, we will do the same. It is very important for you to identify whether is number 2 organic or inorganic. Because if it is inorganic, the inference here is different. And if it is inorganic, like this part, I can say it is inorganic because when you look at the reagents, we have sodium hydroxide solution. The next I have ammonia solution, I have barium nitrate, I have lead. Therefore, this side, number 2, is inorganic. Inorganic. Which tests only the cations and the anions, right? Though that is very important. Cut to question 3. Question 3 is an organic solid, right? Even if when you are not told, you come here and check on the reagents that are being used. Here we are using universal indicator. We are adding acidified potassium manganate. We are using acidified potassium dichromate, then bromine water. That one tells you this one is organic analysis. This is organic what? Analysis. Therefore, in these two scenarios, this one is inorganic and this one is organic. In both, solid F would dissolve to form a colorless solution. Question 3. Question 2, the solid dissolve to form a colorless solution. So some people think, what are you going to write here? And what are you going to write here? So for organic, we will say it is pora. Organic compound, it is a pora. But for this one, it is different. So I hope the difference is now clear. If we are dealing with inorganic, here you will tell us because it is a colorless solution, then it means the colored ions are absent. because we are dealing with inorganic, then it means if it is a colorless solution, then it means Cu2 positive, which is blue, ion 2, which is green, and ion 3 brown are absent. Absent means that they are not there. If they were there, then the solution would be blue. This one is blue, green, and brown, right? Yes. Divide the mixture in B above into 4 portions of almost equal volumes and carry out the following test. To the first portion, add 2 molar sodium hydroxide solution dropwise until in excess. Then the observation is a white precipitate is formed which dissolves in excess. Whenever you are adding sodium hydroxide and a white precipitate is formed, this white precipitate, again, when you put in the reagent in excess, the white precipitate decolorize. It means it changes from a precipitate into a solution. Why a colorless solution? It means ZAP is present. ZAP stands for zinc, aluminum, and lead. Present. These are the amphoteric present. They are present. To the second portion, add 2 molar ammonia solution dropwise until in excess. Ammonia solution is also ammonium hydroxide. So if you see that for that drop written ammonium hydroxide, we are talking about ammonia. So a white pipette is formed which dissolves in excess. Ammonia is specifically testing for zinc 2 ions. So if a white precipitate is formed and that white precipitate dissolves in excess, then it confirms that zinc is present. You see the way I'm writing the chemical formulas? So if it were you, you write like this. You will get 0. You will get 0. This one you print, you write slowly. If you are in a hurry, prepare to get hurry marks. Marks which are in hurry. To the third portion, add 2 to 3 drops. And let me tell you something. Do not write a white PPT. Don't use the shots. They want to ensure that lazy people will not, initially from the 2010 it went up to the to recently 2024 or 2023, they were marking this one. But now they have said they will not mark. If you write PPT instead of precipitate, you will get 0. So that is how the education is changing. So please always write white precipitate, no writing shortcuts. That's how serious it is. No white PPT, and we are adding barium nitrate. First, barium forms a white precipitate with the sulfate, with the carbonate, and the sulfite. So the barium sulfate is a white precipitate, barium carbonate is a white precipitate, barium sulfite is a white precipitate. But now we have been told that no white PPT. So if it is no white PPT, then it means this one are absent. There's nothing else you write. This one you will write present or absent. If you are adding this, a white PPT is formed, a white precipitate is formed, then these are present. Check the way I'm writing the chemical formulas. I am not in a hurry. I'm not in a hurry Sorry. But if you are in a hurry, then prepare. See the way I'm writing the chemical formulas. You come here, you write as if you are running away, as if you want to be a doctor. You see? Present if the white precipitate is formed, because there is no white precipitate, it is absent. No white precipitate, these ones are absent. Don't include chloride. Chloride is only for lead. Chloride, barium chloride is a colorless solution. Please remember that. To the third portion, add 2 to 3 drops of lead to nitrate. A white precipitate is formed, and this what we are told to warm. So you need to include in your observation what happened when you warmed, right? So a white precipitate is formed which dissolves on warming. This white precipitate, when it was formed, it dissolved to form a colorless solution. So this is what I want you to understand. Lead forms a white precipitate with the sulfate, the sulfite, the carbonate, and the chloride. So lead chloride is a white precipitate. Lead sulfate is a white precipitate. Lead sulfite is a white precipitate. Lead carbonate is a white precipitate. But this one, when you warm, the white precipitate dissolves. That's why we say in form 2 that all chlorides are soluble. All chlorides are soluble except lead chloride and silver chloride. Then we give you a note that lead 2 chloride is soluble when warming, after being warmed. On warming, it dissolves to form a colorless solution. So it means that this one is present. This one, if they were present, they cannot dissolve to form a colorless solution. Now, you could say, why didn't I include the sulfate, the sulfite, and the carbonate? Why will I include it here, yet here, from the first one I've said it is absent? So if it is absent, where is it coming from in this, the next one? It will not be there. So it is not coming here because it is absent. So it is this one which is present. Let's move to organic. Number 3, you are provided with organic solid F. Carry out the test below. Write your observations and inferences in the spaces provided. Place about a half of solid F on a metallic spatula. Heat over Bunsen burner flame. So the solid melts and then burns with a yellow sooty flame. If a solid and we are dealing with organic burns with a yellow, then that means it is unsaturated. It means it is unsaturated. So if it is unsaturated, you don't write for us unsaturated here. You give us the functional groups of compounds which are unsaturated, and those we are 2 of them. The double bond. Make sure this carbon is surrounded with 4 covalent bond, comma, triple bond. Put another here to make sure that each carbon is surrounded with present. So I saw some students being confused. If I put it like this, still there's no problem, that is still okay. If you do like this, like this, like this, like this, like this, still it is okay. It doesn't matter where this dash is, so long as it is on this side of the carbon. So either this, or this is okay. Even this one you can write as C triple bond. Instead of putting it here, you can put it here. It is okay. Now we are putting the remaining solid in a test boiling tube, adding distilled water. Then we said about this one, solid F dissolved to form a colorless solution. Because we are dealing with organic analysis, then it means this solid is polar. When in organic chemistry, when we are talking about organic chemistry, a substance which dissolves in water and it is an organic compound, it means that compound is polar. So you say solid F is polar. Is polar. Solid F is polar organic compound. You can even add that. It is not necessary. You can just write polar, organic polar. Why am I including organic? Because I was told it is an organic. But if they said solid F, although I'm dealing with organic, you simply write polar. Divide the solution in above first portion, add 3 drops of universal indicator, and when you check the pH scale with the you check the colors with the pH paper, the scale that you are given. When you compare, you realize that the pH matches the color in your test tube matches to the color on the pH scale of 5. So 5, it is an a weak acid. Then you simply write here weakly acidic. If it was 1, 2, 3, you write strongly acidic. If it was 7, 8, weakly alkaline or weakly basic. 11, 12, 13, 14, strongly alkaline. To the second portion, add 3 drops of acidified potassium manganate 7, which is purple. Then the purple acidified potassium manganate is decolorized. In other words, we are saying the color of acidified potassium manganate changes from purple to colorless. If that is the case, then there are 3 things which are present: the double bond, or the triple bond, or the ROH is present. So don't say the ROH was not here, so you are contradicting. There's nothing here like that. This one is organic analysis, therefore this one tests for these 3. These of them. Don't say that it was not here. Now you don't want to write it here. Don't do that. It must be written. To the third portion, add 3 drops of acidified potassium dichromate dichromate 6. The color of dichromate 6 is orange. So orange acidified potassium dichromate remains orange. It means the color persists. Nothing happened. Don't write nothing happened. The orange color remains orange. The orange color of acidified potassium dichromate remains orange. So if that is the case, this one is always usually expected to change to green. After being warmed, it is expected to change to green, indicating the presence of ROH. Only it is used to test for an alcohol. But now it did not change. It means the ROH is absent. ROH is absent. To the fourth portion, add 3 drops of bromine water. Bromine water is decolorized, then it confirms that a double bond. the triple bond is present. That is what it means. Share, like, and comment. You are provided with solution A, sodium hydroxide, solution B, 0.1 molar. So 0.1 capital M. Capital M implies that 0.1 is the number of moles in 1000 centimeters cube. This is 1 liter. This is molarity. Molarity is the number of moles in a liter. Solution C, 1 mole monobasic acid. A monobasic acid is an acid that contains 1 hydrogen, like nitric acid, like HCl. Solidity 0.5 grams over divalent metal carbonate. Divalent, these are metal carbonate like calcium carbonate, magnesium carbonate, barium carbonate. All those are called divalent because the metal there has got a valence of 2. You are required to standardize solution A. Use the standardized solution A to determine the relative atomic mass of X. Procedure 1. Paper 3 is the most important thing is the procedure. So you need to understand the procedure and analyze what is reacting with what. Fill the burette with solution B. So solution B will contain HCl. That is, the burette will be filled with hydrochloric acid. Using a pipette, transfer 25 of solution A into a 250 ml conical flask. We are putting solution A, sodium hydroxide, into the conical. That is 25. That one, the volume is 25, fixed. Then titrate, record the figures inside here. So the figure I have given you, I'm going to give you these values. The initial, always you can use 0.0. Then the arithmetic, you just copy all these numbers. Make sure the decimal point is consistent and it is visible. By doing this one, you have 4 marks. Then you minus 1 for accuracy. Calculate the average volume of solution B used. So solution B, always put it in mind that solution B is HCl. Now average, before you do the average, look at the values that you have here. The difference, the range from one titer to the other should be plus or minus 0.2. So if it is outside this range, don't use it for an average. 28.1, 30.0, 30.0, you are not going to use 28 as for the average because it is an outlier. It is very outside. So we are going to use only 2. I have used 2 decimals for the average. Average, use 2 decimal places. Write the balanced equation for the reaction taking place. So A is reacting with B. A is sodium hydroxide, B is HCl. sorry, this is HCl. Sorry for that, this is HCl, which is going to give us sodium chloride plus water. So you can, the most important thing is you should know that the ratio is 1 to 1. Sodium hydroxide, when reacting with HCl, the ratio is 1 to 1. The number of moles of sodium hydroxide will be exactly equal to the number of moles of HCl that reacted, the reaction to come to an end point. Calculate the number of moles of solution B. Solution B, what do we know about solution B? We know the concentration, the molarity. So we say 0.1 moles. This one are in 1000 centimeters cube. We will find out the one we used, the 30 centimeters cube, will contain how many moles. That is 30 times 0.1 divided by 1000. And this one is 0.003 moles. You are told to write a balanced equation. Remember to put the status. Put the status, don't forget. Calculate the number of moles of solution A that were used. So number of moles of solution A that reacted with B. So B reacted with A in the ratio 1 to 1. We know the number of moles of solution A. Moles of B, moles of solution B is equal to 0.003. But the mole ratio A and B, A to B, the ratio equal to 1 to 1, means that moles of A in 25 centimeters cube is exactly equal to 0.003. That is a fact because the ratio is 1 to 1. The next thing now that is the number of moles of solution. We are done with that. That is, the number of moles will be the same. Calculate the concentration of solution A in moles per liter. Moles per liter means molarity. Molarity is the number of moles per liter. Moles in 1000 centimeters cube. Now we know the number of moles of solution A in 25. Will you be unable to get in a liter? No. So 25 centimeters cube of A contains 0.003 moles. 1000 centimeters cube, because 1000 of A will contain how many? 1000 is a liter. 1000 times 0.003 we divide by 25. So this one gives us 0.12 capital M. Capital M stands for molarity. So the molarity of solution A is 0.12 molar. M means moles per liter. Moles per liter. Procedure 2. Using a 10 ml measuring, 10 ml is the same as 10 centimeters cube. 1 ml is the same as 1 centimeters cube. So whenever you see ml means a centimeter cube. 250 ml means 250 centimeters cube. Measure 40 centimeters cube of solution C in a beaker. Remember, solution C is the monobasic acid. We only know the molarity. We know the molarity of that acid. Add all solid T and stir using a glass rod until the effervescence stops. Transfer the solution into a 250 ml volumetric flask. rinse both the grass rod and the beaker, transfer into this, top up with distilled water to the mark. Now I want to explain something here. Remember solution C, 4 centimeters cube is going to react with solid T, After reacting with solid T, some moles will remain, but the volume still is 40, right? So the number of moles that remains in 40 centimeters cube of solution of the solution will be equal to the number of moles when we dilute this 40 to 250 centimeters cube in the volumetric flask. So the number of moles that remains after reacting with solid T, after C reacting with solid T, is equal to the number of moles in 250 centimeters cube, the solution we are going to prepare, and call it C2. Using a pipette filter and a pipette filter or filler, transfer this of solution A into a conical flask. So we are going to fill the burette with C2. C2 is the monobasic acid. The difference between C2 and C is that this one is diluted. The concentration of C is higher than this one, because once the T reacted with C, the concentration, some moles were used up. So this is our table: 25.1, 24.9, 25.0. You can see the range is close, and that's okay. So the initial is 0.0. Average, we will do average with everything here because the range is close, is within 0.2, plus or minus. That is it. Calculate the number of moles of solution A in 25 centimeters cube of sodium hydroxide solution B. That one is very simple because we know the concentration. We have the molarity of A. You go back and check the molarity of A. So the molarity of A, we calculated it here, and it is 0.12. So this is the number of moles in 1000 centimeters cube, because I have told you molarity is the number of moles in 1000. We will find out 25 will contain what? 25 times 0.12 divided by 1000, and the answer is going to be 0.003 moles. Now, let's go back to the procedure 2. What is happening? Procedure 2, A, which is sodium hydroxide, is reacting with now C2, and C2 is HCl. Of course, C2 is a monobasic acid. I have told you it is either HCl or hydrogen what? C2 is a monobasic acid. An example of a monobasic acid, it is either nitrogen, nitric acid, or HCl. So N of them, whenever you write the equation with sodium hydroxide, the mole ratio is 1:1, so long as it is a monobasic acid. So A is reacting with C2 and the mole ratio is 1:1, meaning the number of moles of A will be exactly equal to the number of moles of C2 that was used up. So before you calculate it into 50 centimeters cube of C2, you need to know the number of moles of C2 that reacted with solution A in 25. Now, moles of C2 in 25 centimeters cube, because the average of C2 is here. The average was C2 was 25. Since the ratio is 1 to 1, it means that the moles of solution A in 25 will be equal to the number of moles of C2 in 25, which is equal to 0.003. We will find out first. Now we will be able to know 250 centimeters cube C2 will contain how many? 250 times 0.003 divided by 25, and the number of moles in 250 would be 0.03 moles. Now this is the number of moles that remained after reacting with solid T, the X carbonate. This is the number of moles of HCl that remained. Number of moles of HCl that remained after reacting with the T, these are the number of moles that remained. Now, calculate the number, the question begins here, calculate the number of moles of hydrochloric acid in the original 40 centimeters cube of original solution C. Go back and check solution C, what was the molarity? We were given that solution C, it is 1 molar. So this is 1 mole is the number of moles in a liter of the monobasic acid. Implies that 1 mole is equal to 1,000 centimeters cube. We will ask 40 centimeters cube will contain what? 40 times 1 divided by 1,000. And the answer is 0.4. So 0.4 is the number of moles of the original solution C that we picked, that was measured, and then solidity was dropped inside and the reaction took place, and this one remained. So you will be asked, calculate the number of moles of hydrochloric acid that reacted with T. So if this was the original and this remained, how will you get the number of moles that reacted? It is the original minus the one that remained. So 0.01 moles remained of hydrochloric acid. These are the number of moles of HCl that reacted with T. These are the number of moles of HCl that reacted with T. Calculate the molar mass of X carbonate, hence the RAM of X. But before we calculate the molar mass, we need to know the number of moles of X carbonate. What was the number of moles of X carbonate? So X carbonate react with HCl in which ratio? Because this is we were told that these are diatomic, like calcium. Now you can write an equation somewhere like calcium carbonate plus even HCl or nitric acid, assuming that C2 was nitric acid. You realize when you write this one, the reaction is going to be calcium nitrate plus water. The nitrate is 2. So it means that the mole ratio is 1 to 2. So the acid, the mole ratio for the C2, which is the acid, and the X carbonate is that the acid is 2 and the carbonate is 1. That is the most important thing you need to know, right? So if that is the case, then you must know first the number of moles of this. If the number of moles of nitric acid C2 that reacted with this, with the carbonate is this, 1 will be what? So 132 is equal to 0.01. 1 will be what? 1 times 0.01 divided by 2. So the number of moles of X carbonate or T will be 0.005. So from this triangle, we know that RFM is equal to mass over moles, because we have now moles and we have the mass of the X carbonate. We were given that the mass of the X carbonate was 0.5. You go back to what you are provided and refer. So RFM is equal to mass over moles, and that is 0.5 divided by 0.005, and that one gives you 100. So the RFM of the X carbonate is 100, but we were told to find the RAM of X. So X carbonate equal to 100. So X plus 12, that's why you were given this RAM here, plus 12 plus 16 times 3, the answer is 100. X plus 60 will be equal to 100. Therefore, X equal to 100 minus 60, and that is 40. Thank you very much. Share and like, subscribe. You are provided with solution M. So we have solution M, hydrochloric acid. Solution G containing 7.8 grams per dm cube. In the first series, I said, whenever you are given per dm cube, you should know this is the same as 7.8 grams per liter. So it is the same as 7.8 grams per dm cube. So 1 dm cube is equal to 1 liter and is equal to 1000 centimeters cube. So this is one thing. You need to understand that. Then we are given this solid C. Procedure 1. Feel I told you that paper 3 is about the procedure. Understanding the procedure. Fill the purate with sodium hydroxide solution G. Pipette 25 of hydrochloric acid solution M into the conical flask. So you understand that it is sodium hydroxide solution G reacting with hydrochloric acid. It is very important for you to understand that. So that is okay. So the next procedure, this is the volume. So what is in the purate? What is in the conical flask? You need to understand that. So in the purate, we have sodium hydroxide. So the volume we are going to have in the table is the volume for sodium hydroxide. That understanding is important, right? So the 25 that we pipetted 25, that is HCl. So we have 25 HCl, and the volume you are going to get from your experiment is the volume of HCl. In my table, I have the volume. I've always told you initial use 0.0, 0.0, 0.0, and this is my volume. So let's get the average volume. Since this is plus or minus 0.2. So when you look at this one, the difference from here up to here is very big. So we are not going to include this in the average, right? So we are going to do the average with the two values, 37.8 plus 37.9, and then divide by 2, because this one is to outside. So this one will give us 37.65 centimeters cube. Determine determine the concentration of solution G in moles per liter. So solution G, you go back to the procedure and what you are provided with. So when you go here, so we want to calculate the morality. Concentration of solution G in moles per liter. Moles per liter means morality. Morality is the number of moles in a liter. So whenever you are asked the concentration of solution in moles per liter, always that one is morality. So this is the same as morality. So how do you calculate morality? I'm going to give you the formula. So morality, here we have mass in grams per liter. Grams per liter, the same as grams per decimeter cube. Then RFM. So once you have this one, then you know that morality now, you hold morality here is equal to mass in grams per liter over FM. Mass in grams per liter or per dm cube, whichever, per dm cube over RFM. Now solution G is sodium hydroxide. So we are going to get the RFM of sodium hydroxide. So RFM of sodium hydroxide. We have been given here sodium is 23 or that. So that is 23 plus 16 plus 1 and the answer is 40. Therefore, now we apply the formula. The mass in grams per liter we were given of solution is G. So you refer back to solution G, 7.8 grams per dm cube. So you come here and write 7.8 divided by 40 and you get the answer. You use your calculator, you get the answer as 0.195. Capital M stands for morality. There is another way you can do it, though it is a long cut. This one is a now Roman 2. Calculate, the question begins here, determine the concentration of solution M in moles per liter. Remember, solution M reacted with solution G. We know the volumes of both solutions. So what we don't know is the concentration of solution M. So we need to get the moles of the, so solution G, remember G is equal to sodium hydroxide. So sodium hydroxide reacted with HCl. And the reaction goes like this. So this is the reaction. You can see the ratio is 1 to 1. Therefore, we know the volume of sodium hydroxide. It is 37.65. We know the volume of this, it is 25. So what else? We know the concentration of this, which is 0.195 capital M. So this is where we begin. We begin with those that we have, it's the one with its concentration. So we know that this is the number of moles in a liter. So we say 0.195 is the number of moles of solution G in 1,000 centimeters cube. So what about 37.65? Will contain how many moles? 37.65 times 0.195 divided by 1,000. So this gives you the number of moles of sodium hydroxide used, and that is now, since the mole ratio since the mole ratio is 1 to 1, it means the number of moles of sodium hydroxide is equal to the number of moles of HCl used. So meaning moles of 25 centimeters cubed, solution M is equal to 0.00734 because the mole ratio is 1 to 1. So we will ask 1000 centimeters cubed will contain how much? 1000 times 0.00734 divided by 25. And that gives us 0.294 capital M. So that is the concentration of solution M. Procedure 2, using a measuring cylinder, measure out 100 centimeters cube of solution M into a 250 centimeters cube beaker. Add oil solid add oil solid C into the beaker containing solution M. Solution M, it is hydrochloric acid. Solution M is hydrochloric acid. Transfer all the solution into a 250 ml volumetric flask and top up to the mark using distilled water. Label this solution solution D. Fill the bullet with sodium hydroxide solution G, pipette 25 of solution D. Procedure 2, using a measuring cylinder, measure out 100 centimeters cube of solution M into a 250 centimeters cube beaker. Add oil solid C into the beaker containing solution M. Solution M, it is hydrochloric acid. Solution M is hydrochloric acid. Transfer all the solution into a 250 ml volumetric flask and top up to the mark using distilled water. Label this solution solution D. Fill the bullet with sodium hydroxide solution G, pipette 25 of solution D. Into a conical flask, add this phenolphthalein indicator, then titrate. So this is the table I have here, but I want you to understand what is happening in the procedure, because I've always told you the procedure is the chemistry, the practical we are talking about. Now we are adding solid C into a 200 beaker, then it is going to react with 100 centimeter solution of HCl, right? This solid will first react with this 100 centimeters cube. So it means it will consume some moles, but some moles will remain in 100 centimeters cube. So the solid will react with 100 centimeters cube, leaving some moles inside, but some moles will be used up. So remember that. Then now we are topping up into 200 volumetric. Now when we dilute this solution, the remaining solution, into a 250, so you need to know that the number of moles that remained after reacting with solid C, the number of moles that remained in 100 centimeters cube of solution M, the number of moles that remained after reacting with solid C will be equal to the number of moles in 250 centimeters cube solution D. Did you hear that? The number of moles that remains after reacting with solid C is equal to the number of moles in 250 centimeters cube solution that we are going to prepare inside here. That is the critical thing that you need to master. But find the average is simple. Now this one, you look at your value, they are okay, so you just need to do your average. I've said you just write to 2 decimal places. It does not harm, it does not fight. It does not bite, just write 2 decimal places. Next question is calculate the number of moles of hydrochloric acid. Calculate the number of moles of hydrochloric acid solution in 25 centimeters cube solution D. So solution D is HCl but diluted as reacted with solution solution G that we know. So we have several more information of solution G, but D we don't know much about it. But we know that this D has reacted with G. It is D which has reacted with G, but we know G. So G is the sodium hydroxide, and we know the molarity of sodium hydroxide. So we know that 0.195, it is the molarity of sodium hydroxide solution G. So this means these are the number of moles in 1000 centimeters cube. So we will find out the volume that was used. Sodium hydroxide is the solution that was in the purate. Therefore, the volume here is for sodium hydroxide. We will find out the number that is 11.7 centimeters cube will contain how many moles? 11.7 times 0.195 divided by 1000. Now that gives us the number of moles, which is 0.0022815. So you realize that molarity, you write in 3 decimal places, but the number of moles you can write as many decimal places as possible for accuracy. So moles. But we know the ratio, when sodium hydroxide is reacting with HCl, the ratio is 1 to 1. So since mole ratio is 1 to 1, then it means that moles of 25 centimeters cube solution D that reacted with G, 11 centimeters cube of G is equal to this one, is the same. 0.0022815 because the ratio is 1 to 1. The number of moles of hydrochloric acid in 250 centimeters cube solution D. Do you know the reason why we are asking you to find a 250 solution D? You will know why. So this is simple. Now we have moles. We have the moles in 25D. So we will get into 50. That one is very simple. So we will say 25 centimeters cube of D contains 0.0022815 moles. We will simply ask 250 centimeters cube of solution D will contain how many? Is 250 times 0.0022815. We divide by 25, and this one gives us 0.02215 moles. So this is the number of moles in 250. Now the next question is calculate the number of moles, determine the number of moles of hydrochloric acid in 100 centimeters cube of original hydrochloric acid, solution M, original. So original, remember, you need to refer back. We did the molarity of solution M, original. So we had the molarity. Molarity is 0.294. And remember, molarity is the number of moles in 1000. So we have the molarity of solution M. We have the molarity. So you come here, we know that the molarity, you don't need to, I'm writing this for your own good. So you don't need to write this when you understand. So the molarity of M, we know it was 0.294, capital M. So this is the number of moles in a liter. So we will ask that 1000 centimeters cube of solution M contains 0.294 moles. So So we will find out 100 centimeters cube will contain how many? So 100 times 20.294, we divide by 1,000, and we get our number of moles in the original 100 was 0.0294 moles. So this is the number of moles in 100 centimeters cube of the original that used. So when we added solid C, was it solid C? So this solution that we put solid C inside, this is 100. This one, number of moles here initially was this one. So after reacting, the number of moles that reacted, that after the reaction, the number of moles that remained is the one that is in 250. So this is the number of moles that remained after reacting. This is the number of moles that remained. It is calculate the number of moles of hydrochloric acid that were used up in the reaction. Very good. That were used up. That reacted with the number of HCl that reacted with this. Right? I have told you for understanding, for clarification, let me repeat that after 100 centimeters cube solution M reacting with a solid, the 100 centimeters cube remained. The solution remained ikiwa 100. Sawa, sasa ilikuwa 200, hakuna kitu ilifanyika, haikuisha. But what happened is the number of moles decreased because initially ilikuwa na moles and react na solid, so the number of moles decreased. So the moles that remained 100 centimeters ile maji ilibaki wakaongeza hadi ikafika 250. So it means the number of moles that remained in 100 is equal to the number of moles in 250. So that is the thing I want you to know. Therefore, to get the number of moles that reacted with the number of moles of HCl that reacted with solid C, it is simply the number of moles of the original and minus the number of moles in 250 centimeters cube solution D. Very important. That is what you need to understand. That's what you need to understand. Okay, so let's now, the answer here is going to be 0.0294 minus this answer, number of moles minus this one. 0.022815. Now that one gives us 0.00685 moles of HCl. This is the number of moles that reacted with solid C. This is the number of moles of HCl that reacted with solid C. Very good. Because we have subtracted original minus number of moles that remained, so it has given us this. Please understand that. Number of moles, calculate the number of moles of the carbonate that reacted with hydrochloric acid. You need to understand that when a carbonate is reacting with hydrochloric acid, the ratio, mole ratio. So you need to know that. So let me write for you when we have, let me write for you the ionic equation first. We have not been told, but it is important you know. So hydrogen ions in HCl will react with the carbonate in the carbonate ions in the carbonate to form water and CO2. So this water you see has 2 hydrogen, therefore we need to put 2 here. So this means that the ratio is 2 to 1. The hydrogen ions is twice, carbonate is 1. But we have the number of moles of hydrochloric acid to be what? To be 2. Therefore, the moles, because of the ratio 2 to 1, the carbonate is going to have a half of the moles, a half of the number of moles. Therefore, moles of C, that is the carbonate, is equal to a half that of the acid, which is 0.006585. And that one gives us 0.0032925 moles. This is the number of moles of the carbonate. Very important. This is the number of moles of C, the carbonate C. Given that the relative formula mass of carbonate C is 106. Calculated the mass of the carbonate that reacted. So RFM, we have been given the RFM. So how do you get the mass? You can use this formula. You remember this triangle? I have told you we have 3 triangles that are very important. We have this one, the basic one, moles, mass, RFM. RFM is the same as molar mass. Molar mass. So we know if we want mass, how do you get mass? Mass is equal to moles times RFM. So we have the mass of the C that reacted, which is 0. We have the moles, 0.03 2925 times the RFM molar mass, which is 106. And that one going to give us 0.349005 grams. So this is the mass that out of the original mass, which was 0.5, this is the mass that has reacted. Therefore, we want to check the purity. So this was the pure one. So the other remaining is impure. Therefore, how the purity, percentage purity, it is this mass, 0.349005 divided by the original, then you multiply with 100. And this one gives us 69.8%. That is the percentage purity.
Welcome wherever you are. This is Teacher David. I want to take you through Chemistry Paper 3, the year 1998, as we prepare for this year's exam. You are provided with M, hydrochloric acid, solution N containing 8.8 grams per liter of sodium hydroxide. So 8.8 grams per liter, I want to explain this. This means it is 8.8 grams in a liter, or 8.8 grams in dm cube, because 1 dm cube is equal to 1 liter. Those are the key words you need to know. 0.5 grams of an impure carbonate, solid P. You are required to determine the concentration of solution M in moles per liter, percentage purity of the carbonate, solid P. Remember, moles per liter is equal to molarity. What is molarity? Is the number of moles in a liter. So molarity is the number of moles in a liter. So moles per liter is molarity. Let's go to procedure 1. And remember, a practical paper, the most important thing is the procedure. So you need to be, is the procedure. Most important thing is the procedure. Fill the purity with sodium hydroxide solution N. So we know solution N is sodium hydroxide. Fill the purity with sodium hydroxide solution N. Pipette 25 centimeters cube of hydrochloric acid solution into a conical flask. So what we have, so it is HCl that is going to react with sodium hydroxide. You should know the reaction. Sodium hydroxide plus HCl, what does it give you? What is the mole ratio? That is very important. So I have filled the table. Make sure you fill the table with 1 decimal place, and make sure the table is completely filled. Always initial use 0.0. This is no harm, even if you use the remaining, but I encourage you to use 0.0, 0.0. Then put this number here, put this number here, and put this number here, and your table is complete. What is the average volume solution N used? Average volume, that is 24.1 plus 23.9 plus 24.0. You divide by 3. The answer is going to be 24.00 centimeters cube. I have put 00 because we usually say that the average volume should be given in 2 decimal places. Determine the concentration of solution N in moles per liter. I have told you that the concentration in moles per liter is called molarity. So this formula is very important. We have two important triangles in calculation or in the mole. So let me remind you this one. So this one, you write here molarity. Up here is mass, which must be in grams per liter. And then here is RFM. Now, if you are asked N of them, you see what you have been given. Now, solution N, we were given the mass in moles per liter. So look at here, we have N, we have 8.8 moles per liter. So we have mass in grams per liter. We are looking for molarity. We have RFM from here. We have been given this RAM of sodium hydroxide. Therefore, we will get the, therefore we know now that molarity, this molarity, you hold your finger like this, is equal to this over this, is equal to mass in grams per liter over RFM. So now let's get the RFM of sodium hydroxide. RFM of sodium hydroxide NaOH will be equal to 23 plus 16 plus 1, and that one is 40. Now we will have 8.8 over 40, and this one will give us 0.22. Capital M stands for molarity. Also, you can write one as ml per liter or per dm cube, whichever. That one is the number of moles in a liter. Concentration of solution M in moles per liter. Remember, M is reacting with N, and M is HCl. N is sodium hydroxide. So the reaction which is taking place, that's why I told you, you should be able to know how what kind of reaction you expect, and you should be able to write an equation and balance that equation. For this one, it will form sodium chloride plus water, and the mole ratio is going to be 1, 1, 1 everywhere. It means that the number of moles of sodium hydroxide is equal to the number of moles of HCl. Yeah, because the ratio is 1, 1. It is already balanced. Now we know the number of moles of N. We don't know that. We know the number of moles of N in 1,000. But we used N 24 centimeters cube. We can get the number of moles of N we used, then we will know automatically the number of moles of M. So moles of N used, 1,000 centimeters cube of solution N is equal to this, because this is molarity. Molarity is the number of moles in 1,000. M stands for number of moles in a liter. A liter is equal to 1,000 centimeters cube. So this one contains 0.22 moles. Now M, once you write it this way, this one becomes moles and not M. Then now we will find out 24 centimeters cube of solution N will contain how many moles. Therefore, we will say 24 times 0.22 divided by 1,000, and this one will give us 0.0528 moles. Now, this is the number of moles of N used. Number of moles of N used, that is sodium hydroxide. But the ratio here is 1 to 1. It means the number of moles of sodium hydroxide is the same as the number of moles of HCl. Therefore, moles of M used is 0.00528, because the mole ratio is the same. But we are being asked concentration of solution M. Concentration in moles per liter means molarity. So we will say, how much of the volume of solution M used? You go back to the procedure and find out. we were told that pipette 25 of hydrochloric acid solution M. So we used 25. 25 of M reacted with 24 of N, the reaction to reach the end point. So you say now here that 25 centimeters cube is equal to 0.00528 moles. What about 1,000 centimeters cube, which is a liter, will contain how many moles? Now it is 1,000 times 0.00528. You divide by 25. And this one will give us 0.2112. Capital M stands for the molarity. So this is the molarity. This is the molarity of solution M. That is the concentration in moles per liter. It is called molarity. Using a measuring cylinder, measure out 100 centimeters cube of solution M into a 250 centimeters cube beaker. Add all of solid P into the beaker containing solution M. Swirl the mixture and allow the reaction to proceed for about 4 minutes. To swirl is to do like this. So label the solution obtained here as Q. So when after the reaction, the solution that is remained or obtained there is called Q. Fill the puree with sodium hydroxide solution Q. Pipette 25 centimeters cube of solution Q. Pipette 25 centimeters cube of solution Q into a conical flask. Add 2 to 3 drops of screen methyl orange indicator and titrate. So after following that instruction, we will have our table here. I have filled the table like I explained earlier. So let me get the average volume. Average volume, it is 12.3 plus 12.4 plus 12.5. The answer here is 12.40 centimeters cube. Calculate the moles of hydrochloric acid in 25 centimeters cube of solution Q. So remember, solution Q is the solution that remained after reacting with solid P from M to Q, right? So we don't know anything about Q, but we know Q reacted with N. Now we know N, we know the molarity of N, everything about N we know. So we start with calculating N because we know again the Q is HCl, but diluted after reacting with solid P. And M is sodium hydroxide. Sorry, I'm saying we know solution HCl in 25 of solution Q. This is HCl but diluted. So we know the sodium hydroxide solution that the reacted because it has not changed. We know the molarity, but again we know the volume of sodium hydroxide used. It is 12.4. So we know that 0.22 moles. Where did I get this one? We had already obtained the molarity of N here. This was the molarity of N. So this is the number of moles of N in 1,000 centimeters cube. We will now ask, what about moles of N in 12.4 centimeters cube will contain how much moles? So which is 12.4 times 0.22 over 1,000, right? And this one is going to give us 0. So this is the number of moles of solution N that reacted with Q. But the question is asking us to calculate the number of moles of Q. What is the relation between Q and N? This is sodium hydroxide and this is HCl. They will react using the same equation as we saw it here. The equation remains the same because it does not change. This is the equation, meaning the mole ratio is 1 to 1. Since the mole ratio is 1 to 1, it means moles of sodium hydroxide solution N that reacted with Q will be equal to the number of moles of Q in 25. Therefore, moles of Q is equal to 0.002728. Why? The mole ratio is 1 to 1. Calculate the number of moles of hydrochloric acid 100 centimeters cube of solution Q. We know now moles in 25 of Q. What about 100? 25 centimeters cube of Q contains 0.002728 moles. 100 centimeters cube of Q will contain how much? 100 times 0.002728 we divide by 25, and this one will give us 0.010912 moles. So this is the number of moles in 100 solution Q. Calculate the number of moles of 100, the original hydrochloric solution M. Remember, the molarity of M, we calculated it in the first procedure, and we got it like this. Let's go back and refer of M, which is this 0.2112. So we are going to use this one because we know this is the number of moles in 1000. We will ask, what about the number of moles in 100? So 1000 centimeters cube of M contains 0.2112 moles. 2.1, as we have seen on previous, we will ask 100 centimeters cube of M original will contain how much? This 100 times 0.2112 divided by 1000, and this is 0.02112 moles. This is the number of moles in 100 of the original. Calculate the number of moles of hydrochloric acid that were used up in the reaction with solid D. Now, this is to get the moles in 100 centimeters cube solution M minus moles of 100 centimeters cube solution Q. And we have all of that from here. Moles in 100 solution Q, and this is our moles in 100 original solution M. So to get the moles that reacted with P, it is this minus this. And the answer is 0.01028 moles. This is the number of moles that reacted with the carbonate of HCl. This is the moles of HCl that reacted with the carbonate P. Number of moles of the carbonate that reacted with the hydrochloric. Now we know the number of moles of HCl that reacted with the carbonate solution P, solid P. Now what will be the number of moles of P? Here what you need to understand is the mole ratio of HCl when it is reacting with the carbonate. Remember, carbonate has a valence of 2, and this one has a valence of 1 hydrogen here. Therefore, the ratio is 1 to 2. 2 to 1. The ratio is 2 to 1. Therefore, now that we know the number of moles of HCl, the number of the carbonate, number of moles of the carbonate Now that we know the number of moles of the HCl that reacted with P, the carbonate, the number of moles of the carbonate is going to be a half this of this, because we say 2 is equal to this. 1 will be what? 2 is equal to this, what about 1? So it is 1 times this divided by 2, that is a half. And the moles of the carbonate is 0.005104. That is the moles of the carbonate. Given that the relative formula mass of the carbonate is this, calculate the mass of the carbonate that reacted. Mass of the carbonate. Now from the first formula, when you are doing moles, you know that moles is equal to mass over RFM. So mass is, if I want mass, it is moles times RFM. If I want moles, it's mass over RFM. So what I want is mass, therefore mass is equal to moles times RFM. Our moles is 0.005104 times RFM. You have been given 72, and that gives you 0.7488 grams. So this is the mass of the carbonate that reacted. But remember, the total mass of the solid P was 0.5. So the percentage purity, it is the mass of the this is the one that reacted, meaning it was the pure one that reacted with this. The impure one is the remaining 0 point something. But now we want the percentage purity. Percentage purity is this mass over the original, 0.367488 over the original 0.5 times 100. That gives you 73.50%, and that is the percentage purity. So look at this question very well as you prepare for your exam.